An assembly consists of 3 metal plates. The respective areas of the plates are 65,240 millimeters squared, 0.15 meters squared, and 850 centimeters squared. Determine the total surface area in meters squared, considering precision and or accuracy. Since we want to have the final answer in meters squared, we would convert all these areas into meters squared and then add them up. The first area is, I'll call it A1. A1 is equal to 65240 millimeters squared. I know that 1 milli is 10 to the power of minus 3. In other words, 1 millimeters is 10 to the power of minus 3 meters. Therefore, I can say that A1 is 65240, and instead of millimeters squared, I can write it like this, so it's quite obvious what we're dealing with. 1 millimeter to the power of 2. I can write instead of that 10 to the power of minus 3 meters squared. And this becomes 65240 times 10 to the power of minus 6 meters squared. I have used this property that A times B squared is A squared B squared for any A and B. And this number can be simplified to 0.06524 square meters. This is the value that we have for the first area. The second area is 0.15 square meters. Because this area is already a square meter, we leave it the way it is. The third area is equal to 850 centimeters squared, and I would like to convert this quantity to meters squared so I can add this to the other two quantities. I note that 1 meter is 100 centimeters. In other words, 1 centimeter is 10 to the power of minus 2 meters. And we could have also thought of this as the prefix centi, which means 10 to the minus 2. Therefore, for A3, I can write 850 instead of 1 centimeters squared. I can write 10 to the power of minus 2 meters squared. And once again, I can write this as 10 to the minus 4 meters squared, which would be 0.085 meters squared. Therefore, the third area is also in the units of meters squared. The total area would be A1 plus A2 plus A3, which is 0.06524 meters squared plus 0.15 meters squared plus 0.085 meters squared. Since we are simply adding these values, we should pay attention that what really matters is the precision rather than accuracy. Therefore, we should consider the decimal places in order to determine the precision of the final answer. If you add these numbers together, you would get 0.30024, and we know that not all of the decimal places are reliable. To determine how many of these decimal places are reliable, we need to look at the decimal places of the original number. The first number is precise to 5 decimal places. The second number is precise to 2 decimal places. And the third number is precise to 3 decimal places. The least precise number is 0.15, which is precise only to 2 decimal places. Therefore, only 2 decimal places of the final answer are reliable. We would round this number, therefore, to 0.30 square meters. And this would be the final answer to this problem.